Hello, welcome to NPTEL online certification course on Introduction to Application of AI to Robotics. Today we are going to discuss about machine learning, okay, a very important topic in the AI. Okay, so the learning objectives of this lecture are that you will be able to understand about the machine learning and why it is necessary for modern robotics. Then you will be able to understand what the intelligent systems are, and you will be able to distinguish between the three important types of machine learning, say supervised, unsupervised and reinforcement learning. Specifically, I will be focusing much more detail in the supervised one in this lecture, and the other two I will be taking it up in the next lecture. Okay. So, this is how I have arranged the content for this lecture. Initially, we will be seeing why we should use machine learning in robotics, what are the intelligent systems, then we will be defining the machine learning, and further we will be seeing the classification of machine learning, and as I said in the previous slide, we will be seeing in detail the supervised learning, and we will be seeing the two types of the supervised learning, which are classification type, that is the k nearest neighbor, and the regression. Okay. So, why machine learning? What is motivation for using machine learning in robotics? Okay. You see that whether our robot navigate in unstructured warehouse, right, or manipulate some object, or it has to interpret the natural language commands, or collaborate safely with humans, say in the human robot interaction. Okay. So, these are the situations where the exhaustive hand coded rules simply break down. Okay, because to take care of this type of situation, if you like to have the hand coded rules, they are going to be enormous. Okay, so simply just not possible to write the hand coded rules for this one. Okay. So, you see the machine learning provides the tool that allows the robot to improve their behavior by what? Using data and experience, okay, rather than from the explicit programming. In the introduction week of this course also I have introduced this topic to you, okay. So, that is much more basic, and here we are seeing the further details of that. Okay. So, the machine learning is a field which is at the intersection of, say, statistics, artificial intelligence and computer science. So, first we understand the rule based intelligent system and what are the limitations of such a system. Okay. So, how does the rule based intelligent system looks like, okay, and what are its limitations? So, you see these rule based intelligence system were mostly based on the if then else type of decision rules. Okay. This methodology was known as the expert system or the knowledge engineering. And these expert design system only possible when human have a very good domain specific knowledge actually. Okay. If one person has got a very good domain specific knowledge, then writing the rule based codes is much easier for him. But you see this is not always possible. Okay. So, a very classical illustration of the rule based system which I have been talking about is that of the spam email filter. Okay. You see in such a system what we do, we usually manually curate a blacklist of words, because we have to identify which email is spam email, right, out of whatever email you receive in your inbox. So, we manually curate a blacklist of words, okay, or phrases that the mail may contain. Okay. So, if detected in an email with the blacklist word, results is a message and being marked it as a spam. And now you see here each rule is authored by the human expert, okay, who is expert in the specific domain. Okay. So, to see the specific example of intelligent system email filter, okay, so we have written a small code for that. In this code, if you see, we have blacklisted some words, say if your email has got this type of words, say free money or click here or win prize or urgent. Okay, so in this type of emails which have these words, okay, so we can flag. How do we do? So here first we convert the text in the mail into a lower form, okay, and then we look for these words basically in the email, okay, and if that is there we mark it as the spam, otherwise it is a non-spam. Okay. So, for example, say your email have got this type of content, you have won a free money prize, click here now, okay, or meeting agenda for tomorrow is attached, Nigerian prince offers complimentary financial assistance, okay, and get your free products today at no cost. All right. So, for these 4 inputs, okay, here are your output. First one, it will be identified as a spam because the free money which we have put in this word, that is there in this one. Okay. So, this is marked as a spam, but the second one is not marked as spam because none of the words in the second one is there in the blacklist category, and you see the third one will also be not marked as spam because again these words are not there, but by reading this content we can say that it is a way of evading the spam filter. Okay. And the fourth one gets a free product today at no cost. Okay. So, instead of free money, here it is written the free product. Okay. So, again since the free product is not there in the blacklist, it is going to evade your spam filter. Okay. So, this is your email filter intelligent system. Okay. And you can see the limitation of this one. As I said, one need to be very expert in the domain of in which this filter has to be created. Logic is designed for single narrow task. Okay. Any change to the task or operating domain requires entire rules to be rewritten. Okay. So, that is one limitation. The other limitation is human experience dependency. Okay. That is, designing the rule depends on the deep understanding of how a decision should be made by the human. All right. So, it is dependent on the human expertise. Okay. If human is not very much expert, then it may have the issues, right. Further limitation is the cognitive computational mismatch. What is that? Okay. You see, the way human understand and process information is fundamentally different from how a machine process the same information, right, because we recognize a face holistically, where machine has got information pixel wise and arranged in the form of the arrays. Okay, so this cognitive computational mismatch is there. Okay. Further, you see that the rules written from human cognitive perspective may not translate well in machine execution. So, that is not possible. So, here we have taken an example how a number 0 is seen by say a human and how a computer sees number 0. Okay. So, you see that this is a 8 cross 8 pixel grid, okay, where this human identifies this number as 0, but the computer will identify this number, okay, using the information such as the pixel intensities. It is a 8 by 8 grid, right. So, here the first row is this one 0 0 180, this 180. Okay. Then you have the other numbers being. Likewise, we have the information of all the 8 rows, okay, where basically these numbers represents the pixel intensities. Okay. So, you see a standard image has 256 possible shades of gray per pixel. Okay. So, here 1 pixel can have value from 0 to 255 because there are the 256 possible shades. All right. So, and in this 8 cross 8 grid we have the 64 pixels, right. So, in total we have the 256 to power 64 possible combinations of pixels, okay, and manually coding for this number is just impossible. Okay. So, one has to understand the limitation of the conventional intelligence system which are rule based. Okay. Machine learning can overcome that limitation. Okay. But before that, let us understand what is machine learning. So, here rather than being explicitly programming with the rules as we have seen previously, machine learning systems learn patterns, okay, and that pattern learning comes from the data, all right, and use those patterns to make decision or prediction of any new or unseen data. Okay, so the machine learning code essentially comprises of 4 steps. So, what we do, first we load the data, and then we split the data on the training and the testing, okay, the two part, and then we train, and then the finally predict it. Okay. So, these are the 4 steps in the machine learning code, all right. So, here is a simple example, say what all we are doing here. We are importing the data set, then we are importing this k neighbors classifier. I am going to talk about this little later, okay, and then model selection, basically the splitting of the data. Okay. So, I can split data x train and x test and y train and y test. Okay. So, this way we can do, and output accuracy could be even up to the extent of 97% possible through this. Okay. To understand further the difficulty of the rule based, okay, and how the machine learning code overcome the limitations of the rule based code, okay, let us take this iris classification. Okay. So, you see the iris has got these features such as sepal and petal. Okay. So, if I have to write a rule based approach, then I can say that, okay, if sepal length is say less than 5 centimeter, then return setosa, it is a classification basically, and if this petal length is less than 2.5 centimeter, then return setosa, like that, okay, or else return versicolor, this one. So, for this you have to write this code, all right. And even if you have to include the other classification, that is Virginica, then again you have to write about that, okay, here. But in case of machine learning, what we do basically, we load this data set, okay, we use a classifier, and then we split the data, right, and then of course we pass the data through this classifier and we get the result. Okay. So, in rule based, as I said, need domain specific knowledge, and complexity increases as the number of classes increases here, whereas in the case of machine learning one, it selects model and task, and then you load data and then upload data in model. So, what type of problem machine learning can solve? Okay, as a robotics engineer, what type of problem I can expect that machine learning can solve for me? Okay, so the problem that require automate decision making process. Okay, so and that by generalizing from known examples. This is what we call supervised learning. I will be coming in little later. Much more details into that. Okay. So, for example, say self driving car or object grasping or quality check in industry, and the problem in which only input data is known, okay, and we do not have any known output data, okay, and that is what we call as unsupervised learning. Okay. So, this is there for say mapping of the environment SLAM. Okay. Then segmenting different type of walking terrain. All right. So, if your say robot is a walking robot and moving in a terrain, what type of different terrains are there? All right. Then say detecting abnormalities in the robot, for that purpose we can use. Okay. So, in both type of problem, it is important to have a representation of input data that a computer can understand. Okay. So, you see we can classify the machine learning, okay, based on the what the nature of learning task is that, and the type of feedback is provided. Okay. So, basically there are 3 types of machine learning classification. These are the supervised learning, unsupervised learning, and the reinforcement learning. Okay. So, understanding this classification is actually very important, because then only we will be able to select which type of algorithm I should apply. Okay. Let us begin with the supervised learning. In this lecture, I am going to talk a detail about the supervised learning. Other unsupervised and reinforcement learning I will be talking in next lecture. Okay, so you see machine learning algorithm that learn from input output pair, that is what we call a supervised learning algorithm. Okay, so we have the input information, we have the output information corresponding to the input information. Okay, so what actually is done in this case? So in this framework, user or teacher provides the algorithm with the data set consisting of input output pair, okay, where the output represents the desired result for the specific input. Okay, and the algorithm then extracts, okay, regularities or mapping from these examples, okay, and then builds a model basically, and that model can be used to do the prediction, okay, a prediction for the new type of input, okay, that could be done. Say for example, the data of the robot hand, okay, with say input feature, say the force that is feature 0 and slip say feature 1 is given with labeled output, okay, for grasp result, okay, that is say class 1 fail, where the gripper is not able to grasp the object, and the other is that class 0 that which is success, where the gripper is able to grasp the object. Okay. So, I could plot this feature 0 and feature 1 here. Okay. So, this is the force and this is the slip. Okay. So, this way we can do. So, to understand this just means if your force is going to have minimum value, naturally your chances of slip are going to be maximum. Alright. So, this way it is there. Alright. So, here you see we have the two grasp result and these are fail, and that is class 1 and class 0. Okay. So, the algorithm learns to create a decision boundary between class 0 and class 1 data point. Okay. So, here is this decision boundary, and say this red area belongs to class 1 and blue area belongs to class 0. Okay. So, this way the algorithm can create the decision boundary. And okay, now if your new data comes, alright, say here, okay, then we can directly say that this belongs to the class 0. So, this way we can predict, okay, based on its position. Okay. There are two major types of supervised learning. Okay. These are primarily categorized based on the nature of the output they aim to predict. Okay. So, in the classification, the goal is to predict a class level, okay, for the given input. Okay. And based on the number of classes, we can have say the binary class or multi-class, okay, what algorithm we are using, say k nearest neighbor, decision tree, support vector machine, logistic regression, and so on. And these are measured by say accuracy, precision, and the recall. So, this is all about the classification. Okay. Next type of supervised machine learning is the regression. Okay. So, in case of regression, the output is a continuous numerical value. Okay. It could be real or the floating point number. Example could be say house prices, your temperature, okay, or estimate the force needed for the gripping, okay, by a gripper. And the algorithms could be say linear regression, REACH and SBR. And here measurement we are doing using say mean square error, okay, or mean average error, R square, and so on. So, let us look a little detail on the k nearest neighbor, which is a classification algorithm. So, you see this algorithm is simplest machine learning algorithm, and how does this work basically? So, we stored this input output data, okay, the training data set, okay. So, you have first feature and the second feature, okay, and the class 0 and class 1 can be marked here, okay, and then we put our new data point, and then we find the closest point in the training data set. That is why it is called the nearest neighbor. Okay. So, how we do that? We find the Euclidean distance, okay, of the neighboring data point, say D1, D2 and so on. Alright. So, evaluate D1 and evaluate D2. Okay. So, here basic concept is that the nearest class is going to be the prediction for the new data point. Okay. So, from this new data point, the minimum class distance, okay, that is going to be the classification of new data point. Okay. So, basically algorithm assumes that similar instances have similar output, meaning they are located near each other in a feature space. Okay. So, basically you predict the class output. The D1 is here smallest. So, this is the class 1. Okay. Now, in the previous slide we just compared one closest neighbor. Okay. But instead of comparing one closest neighbor, if we compare many neighbors, okay, say arbitrary number k, okay. So, this is from where this word has come, the k nearest neighbor, okay. And in this case what we do, we use voting to assign a label basically, okay. So, assign the class that is more frequent, in other words majority class among the k nearest neighbor, okay. So, in this case for this data point 1 is near class 0, okay, and 2 are near class 1, okay. So, here basically the prediction for this is going to be that of the class 1, because 2 such neighbors are there which are closer, alright. And in this case of test point you have all the 3 are of the same class, which is of class 0, okay. So, for the test 1 you have the 2 class of 1, and for the test 2 the 3 class 0. So, here basically I have taken the 3 neighbors, okay. So, the k value is 3 here in this case, okay. So, the selecting k determines the algorithm performance and the decision boundaries, okay. So, basically you see what we are doing, based on how many neighbors we are evaluating, our decisions are changing, right, our class are changing. So, what does this means basically, okay, that based on the number of neighbors you are choosing, okay, your decision boundaries are going to change, okay. So, in this case say one neighbor, this is the decision boundary. With the 3 you could have this as the decision boundary, and with the 9 you could have this as the decision boundary, because with more number of neighbors your decision is going to change, right. Okay. So, we can take an example of say a robot is moving in an unknown terrain, okay, and we will use vibration sensor to guess the terrain type, whether it is smooth floor, gravel or grass. This is the example, right. Say mobile robot moving on a smooth floor, mobile robot moving on a gravel, and mobile robot moving on the grass, okay. So, here basically the data architecture could be like this. Input feature we could have the speed and the vibration data, and the output feature will be just classification, whether it is a smooth floor or gravel floor or the grass, that is class 0, class 1 and class 2, okay. So, the smooth floor will have low vibration, so we can have the this one class 0, medium vibration class 2 and high vibration class 1. Okay, and we can use the k nearest neighbor classifier. So, here the sample code is written, we import numpy, that is the core math library, then we import matplotlib for plotting purpose, that is the data visualization, and from sklearn, okay, we use this k neighbors classifier, okay. And this is some synthetic data which we have generated, okay. Say for the smooth floor, this is velocity and this is the vibration data, right. This is velocity and this is vibration data. So, this is for smooth floor, this is for the gravel floor and this is for the grass one, and here is the output basically which we are indicating, okay. So, first 2 are basically that is for the corresponding to the flat floor, okay. So, 0. Second 2 are for gravel, okay. So, this is a 1 and the last 2 are corresponding to the grass, so 2, alright. So, this X terrain is our feature matrix basically, and it contains 6 past experiences of speed and vibration. So, this is a 6 cross 2 matrix basically, right. Okay. So, we can select the k nearest neighbor classifier here, and we define this k nearest neighbor as 1 as synthetic data is small, okay. We have only 6 data points here, and this dot fit feed data into the model here, alright, and then we give the new point, okay, say the velocity and the vibration data, alright, and then we ask it to predict, okay. So, for this say 0.7 meter and 62 hertz, okay, naturally it is going to say that it is gravel, alright. So, it will be predicting that one, alright. So, the model measures the Euclidean distance to all data points in its memory and assign a class based on the nearest neighbor, right. So, this is the terrain classification, okay, based on the robot speed and vibration level. So, we have these two data, and these two data, okay. So, we have total 6 data and this is our the test one. Okay. For this speed and this vibration level, it will be telling that it is a gravel basically, alright. Okay. Last part of today's lecture is the regression, where I am going to talk about the linear regression. Okay. And you see, linear regression is also known as ordinary least square, okay. And this is the simplest, most classical supervised learning model, okay. And here our primary goal is to predict a continuous numeric value, alright. To find the linear relationship between input and output basically, or the target variable, we have a mathematical model, okay. So, where output is given by this equation, where your x0 to xp defines the feature of a single data point, w and b are parameter of the model that are learned, and y is the prediction, okay, which the model predicts basically. And if we are using data for a single feature, then this equation could be w0 into x0 plus b. That is, we are going to have only this term and this term. Okay. So, we have this training data here. So, this is my input and I have my output, and I have plotted all this training data. Alright. So, what I have to do now? I have to get an equation which could predict this data with the least square error being minimum one, right. So, we have the training data set, this one which we have already plotted, initialize model with assumption values, okay, this one, alright, and find the parameter w and b basically, right, to minimize the mean square error. So, we could update this w and b till we find the minimum value of the mean square error, okay, and with optimized parameters get this expression, alright. So, here in the supervised learning, we can consider the various robotics examples where this supervised learning can be useful. Say for the object recognition using camera, our input could be image pixel, okay, and object could be a class, what type of object it is, cup, bottle, tool, face and so on. Then graph success prediction, okay, it could be point cloud plus the gripper pose, and the output could be success or failure in the grasping. Then in case of the actuator fault detection, we could have the torque, time, velocity, time series as the input, and output could be the fault type. Similarly, the human pose estimation, input could be depth image and output could be 3D joint coordinate, okay. Similarly, for the terrain classification through LiDAR, your input could be the LiDAR scan feature and output could be the terrain type. So, to summarize this, you see, the machine learning is the discipline of learning model from data basically, rather than doing the manual encoding. And it is essential in robotics because we have lot of more sensor being used, and those sensors collect data, okay, and for those sensors data it is very difficult to write the code, okay. So, there are three major paradigms which we have seen: supervised, unsupervised and reinforcement. Today we have seen the supervised one, okay. Then every ML data set has a consistent structure, okay. You have rows, that is a sample, and then you have the feature which are column, and for supervised task label are the target values basically, okay. So, with this I would like to say thank you. We will continue this in the next class, and yeah.